Welcome to clickmyproject.com. We will discuss about the product for Rate-0.96 LDPC decoding VLSI for soft decision error correction of NAND flash memory. Next, we will see the abstract for the product. NAND flash memory is widely used in many mobile devices such as the cellular phone, digital cameras and smart plates because a high capacity, fast access speed and low power consumption. In a particular, solid state drives for a notebook computer have become a popular high density NAND flash memory devices are available. NAND flash memory stores that the information changing the threshold voltage of floating gate transistors. Most of the today high density NAND flash memory devices store the multiple bits in a cell. The multi-level cell technology significantly increased the bit rate process. The reliability of data stored in high-density flash memory devices tends to decrease rapidly because of the reduced cell size and multi-level cell technology. Soft decision error correction algorithm that use the multiple precision sensing for reading memory can solve the problem. However, they require very complex hardware for high throughput decoding. In this paper, we present a rate of 0.96 shortened equivalent geometry low density parity check code and the VLSI implementation for high throughput NAND flash memory systems. The design employs the normalized probability based algorithm, serial schedule and conditional update which leads to simple functional unit halved decoding iteration and low power consumption rapidly. A pipelined parallel architecture is adapted for high throughput decoding and memory reduction technique are employed to minimize the chip size. Next we will see the flow diagram for the product. First of all, the NAND flash memory is used to input data to apply the NAND flash memory architecture and the input data to be stored in the correct address for the bit locations and the data bit first we write given the specified location and to read the exact memory location. The NAND flash memory is to be considered the array of memory location based on the NAND based storage process. Node processing unit. The node processing unit is to find the NAND flash memory data and to apply the node processing architecture results. The node processing unit is to find the memory data and to modify the input memory value and to improve the node processing level. The node processing level is to process the decoding methodology using the LDPC decoding technique. The min selector is to find the magnitude value of to be select the node processing unit. The node processing unit is the decoding the all logical blocks and to apply the logical element for the processing architecture. APP memory. APP memory, the decoding hardware employs the normalized posterior probability APP based algorithm that not only simplifying both of the variable check node and to appropriate the good error correcting performance for the geometric LDPC methodology. The APP memory is to modify it based on the node processing values and to apply the input selection process. So we use the shift register for the parity check processing in the APP architecture. VIVT design management. The VIVT design process used to connect the APP memory architecture and the technique used to improve the error correction process because VIVT design is calculate the shift register and parity check noding process for the APP architecture. Then the result is to apply to the parity check processing and to calculate the add parity and even parity, then calculate the XOR functions and to correct the error functions for the single bit error in LDPC decoding methodology and to finally pass the output buffer result and to finally get it to the weighted bits for the given input to the NAND flash memory architecture. And finally we discuss about the output for the product. Just we open the Xilinx ISC project for the NAND flash memory architecture device. Our project is developed by the VHDL language and used to the structural modeling process. Then to select the LDPC process and simulation, to select the LDPC, then to double-click the simulate behavior model. The simulation process to be run and the process is to be successful, then create the ISM project. Then to apply the binary input for the simulation result and to check the result for the processing performance, and to apply the any of the input address, then to activate the writing and reading process, then to create the input data signal, to apply the main functions, then apply the sign and input functions. Just we run the, then to activate the clocking signal and remove the then to calculate the WN weighted biting process and to select the input signal to the first selection line process, then the output weighted bits for the our required LDPC decoding methodology, then to select the implementation process and to select the shift register EGLDPC work methodology, to right click the run RTL schematic diagrammatic representation and to follow the technological diagrammatic representation also. Then the RTL diagrammatic representation to be applied, the NAND flash memory and node processing unit to be processed. Just we calculate the node processing architectures. These results are the LDPC decoding methodology. Then these RTL diagram to represent the what are the logical block present in the LDPC architecture. Then the technology diagram to represent the what are the lookup table and input output connections. Then the buffer element and the flip-flop pairs elements to be placed in the our LDPC decoding architecture. Then calculate the design summary results and to select the synthesis report. Just we process the device utilization for our LDPC architecture. Then to calculate the processing time allocation and processing frequency, then path delay allocation and latency level for the LDPC architecture.